Welcome back. We continue our study on enthalpy by looking at some different names that we call different enthalpies depending upon the type of reaction that they're in. It's really easy, it's just names. Let's review first. We remember that the heat content, which we call enthalpy, capital H, is simply the amount of energy stored in the bonds of all of the products minus all of the energy stored in the bonds of all the reactants. And we looked at before, if you end up with a negative delta H, you've got heat that has escaped and it's an exothermic reaction. And if you have heat stored in the products more than in the reactants, and the energy actually had to come from the environment, we call that an endothermic. Let's look at it. This is a diagram or a thermochemical diagram, and it just shows what we just said. The exothermic reaction here you end up with lots of stored energy in the bonds, but in the products here you ended up with very little stored energy in the bonds, and the heat was released as a result. That's exothermic. Endothermic is the backwards. You have a certain amount of energy stored in the reactant bonds, but much more stored in the bonds of the products, and the energy actually had to be sucked out of the environment in order to store it into the bonds. So when we see that it's not, the enthalpy is not exactly built into it, it's based upon how much is released. So if you had lots and lots of reactants, you would have lots of heat released. So imagine putting 1 log on the fire or 10 logs on the fire. The more logs you put on the fire, the more heat is released. That's an extensive property. So it's based upon how much that you start with. So let's look at these different types of names, different types of enthalpy changes we just give different names to. So the first one is the heat of reaction, and this is what we just call a normal chemical reaction. The delta H of any reaction is called the heat of reaction, and it's the enthalpy of the products minus the enthalpy of the reactants. So here's an example. We've got hydrogen gas and oxygen gas reacting to form water, and we see that even that this is going to release an enormous amount of heat. When those two gases come together to form water vapor, it's going to release 483 kilojoules of energy. If you were to go backwards and take water and separate it into the amount into oxygen and hydrogen, like we did with the battery and the water and the platinum wire, it actually takes energy to do that. It takes the same amount of energy that's released. It takes 483 joules. So that's heat of reaction. This, by the way, is called a thermochemical equation. It's got the stuff that's reacting and how much energy is released or absorbed. The next one is the heat of combustion. If you combust something by burning it in the air, we just call that the heat of combustion. And you know that if something burns, like wood or natural gas or something like this, it's going to release energy. So it's going to have a negative delta H. In the case of methane gas, natural gas, it's a lot, 890 kilojoules of energy per mole of reaction. If you form a substance from its elements, so in this case I've got hydrogen and carbon reacting together to form methane. In this case, this is called heat of formation. It's the amount of energy change or enthalpy change simply by making something out of its component elements. So hydrogen and carbon coming together to form methane, that would be heat of formation. And finally, we see that even not just a chemical reaction, but a phase change. So if something melts or something freezes or something evaporates, there's going to be a different amount of energy in that. For instance, steam at 100 degrees has a lot more energy than water at 100 degrees. So if you turn a liquid to a gas, and whatever change that is, that's called the heat of vaporization. Solid to a liquid is the heat of fusion, and the solid to a gas, going straight off to a gas, is called the heat of sublimation. So I hope this helps. There's lots to write down today, but this will help later in future sections. Thank you.